hear me now on Zoom? I hope so.
Yes.
Okay, good.
Finally.
Here's our lineup. We'll have announcements and whatnot. And then Richard will be giving his members corner presentation about a really cool 1884 Alvan Clark 10-inch refractor that we came across. It was donated. It's so cool. And then we'll have our refreshment break. And then we'll transition into one of the planetarium shows by James Albury, Exploring New Horizons. Okay. All right, since our meeting of 2 weeks ago, we have one new member, Stephen Weber. Are you here? Welcome. And our visitors, Tom Ruger, are you here? Welcome, Tom. David Lyles? All right. Marley Chevy? Okay, I'm sorry, I couldn't read it. Welcome. Well, John and Linda Pinto, welcome. All right. We're up to 189 members. That's a good crowd. Okay, so coming up real soon, next week, Dava Sobel will be our guest, and that's a Zoom session that we have. And she is the author of that and several other really highly acclaimed and awarded books. I listened to this one, audio version, Glass Universe. It's about the ladies of Harvard Observatory and how they came up from being just what were called computers to being very significant contributors to astronomy. So it's really good, and I'm sure Rich Russin will have some outstanding questions for her, and then you'll be able to chime in and ask questions as well. But that's next Tuesday, 7 p.m. via Zoom. So if you register at the website, then you'll get the link and you can Zoom in. You won't want to miss that one. It should be good. Okay, and then next week's going to be busy. I have a star party coming up at Chiefland on Saturday the 19th, and we always try to arrive an hour prior to sunset. So again, please register to attend, and that way, if you've never been there, you get directions on how to get there. And then, as always, there will be an email sent out by noon on whether we're go or no go due to weather. That's a shot from the large dome at Chiefland, and it's really dark out there. It's wonderful. Okay, the next ATM is going to be about telescope information and support. So be a presentation about telescopes and the different types. And then some folks will bring some of their telescopes to have on display and answer any questions folks might have. And then we'll do a telescope tune-up. So if you need help with collimation or mirror cleaning or anything like that, folks there can help out. And then if the weather cooperates, we'll do a little solar viewing. So volunteers are welcome. I think Matt's got a couple already, but could use more. Is that right? Okay, that should be a good one. So we'll let you know location and time when we establish that. Okay, the Chiefland Astrofest is coming up in October, and there are still tent sites available and a few sites for regular sized RVs. So not the big motorhomes, but something like the ones you see in the picture there. And again, that's another example of the wonderful dark skies out at Chiefland. And the Astrofest has a lot going on. There's a swap meet there in the top left corner, lots of goodies that folks want to pass on. We have some outstanding speakers at all of the Astrofests. The bottom left, that's the raffle. Matt has outdone himself. He has over $11,000 worth of donated telescopes and whatnot that will be raffled off. You don't want to miss that. And he's multi-talented. He knows how to flip a burger. So there's plenty of food at that event too. So you don't want to miss that one either. Hey, I don't know if you heard, this was just out today. Scientists have figured out finally how Ayers Rock was formed. Has anybody ever been down there? Okay, that's amazing. And I tell you, they were kind of embarrassed that what they figured out was right in front of them all the time. When that meteor hit in Arizona, it made it go boink down on the bottom. Not buying that, huh? Okay. All right, are there any announcements that anyone has? Okay, if not, I'm going to press on. Before Richard speaks, I want to show my last few slides, and then we won't have to be swapping back and forth. Right after I'm done, of course, we'll have our intermission outside. No food or drinks back in here, and it'll last 15 minutes. So be sure to say hi to our visitors and new members and shake that man's hand right there. And then after that, we'll all come in and we'll hear from James about the Exploring New Horizons. Now, the young lady who was supposed to speak tonight, well, hopefully she'll be able to be the presenter next month. So stay tuned on the website. And then Members Corner next month will be our own Hal McAllister tell us about a Pluto experiment he did with one of his telescopes. So he, as you know, is an outstanding speaker. So with that, I'm going to hand it over to Richard.
So thank you all for coming. I'm going to give you today a presentation about a project we started at the Chiefland Astronomy Village. You've heard about Steinway's pianos and Stradivarius violins. Alvan Clark telescopes are their astronomical cousins, handcrafted world instruments from a golden age of discovery. But there's a surprising part. Fewer than 50 large Alvan Clark refractors still exist today. And there are fewer than 10 available for the public to actually look through. None in our region. I'm Richard Hennig. I'm the director and curator of the Chiefland Astronomy Heritage Museum, located at the heart of the Chiefland Astronomy Village near the Florida Nature Coast. Today, I'll take you on a journey that some of us here have begun. One with a bold goal: to save a once-in-a-lifetime treasure, an 1880s Alvan Clark refractor telescope. Thanks to a generous donation by Mike Toomey, this historic instrument has found a new home with us. But it urgently needs restoration for it to survive and inspire for future generations. For this journey, let me see. Come on. The slide's not coming up. Oh, there we go. Okay, thank you, I got it. So for this journey, we need to go back in time. And since we all know that time travel is just science fiction, we need to use a different method to see Earth at the beginning of the story in 1834. Well, we'll just use an FTL drive and a wormhole, and that will take us in a near instant to Zubin el-Shemali in Libra. Zubin el-Shemali is, come on, you gotta go to the animation. Zubin el-Shemali is 191 light years away from Earth in the constellation Libra. If you see it, there it is. Okay, wormhole going, almost there. Here we are. Destination 1834. Lucky for us, in our storyline, Zubin el-Shemali has a planet that is just right for life. So we can go there and observe Earth as it was in 1834. From our vantage point across the stars, we watch a visionary, John Gumier, one of the founders of Haverford College in Pennsylvania, not far from Philadelphia. In 1839, he proposed a humble wooden observatory at Haverford College. That observatory housed only a transit instrument, shown here on the left, an astronomical clock, a portable telescope, and a sextant. A little over a decade later, in the early 1850s, the mathematics lecturer Hugh Vail began a push to create a more serious astronomical facility at Haverford. With permission from the college's managers, he began laying the groundwork for a proper observatory. Vail noted this was the initial move toward getting a real observatory. A fundraising campaign was launched to acquire a larger equatorial telescope. And in 1853, Haverford acquired a new 8¼ Fitz refractor. The price of that scope was $1,950 in 1853, which is about $68,000 today. There are no pictures of that Fitz refractor surviving. So instead, let's look at some of the ads from that time, here in the middle and on the right, and look at a photo of a similar sized refractor. It's a 7-inch refractor at Erskine College in South Carolina. Quite beautiful and nice instrument, but we're not at the Alvan Clark yet. Well, enter the Alvan Clark era. Now we enter the era of America's most celebrated telescope maker, Alvan Clark. By the 1880s, the Fitz telescope at Haverford College was becoming outdated, and it was time for something bigger. In April 1883, under the leadership of Isaac Sharpless, professor of astronomy, and later also president of Haverford College, the college launched a campaign to acquire a modern 10-inch telescope. Within 6 months, Sharpless raised $4,075, that's approximately $143,000 today, through private donations. And the board of managers approved the purchase of the Alvan Clark refractor. To house the new Alvan Clark refractor, the college constructed an additional building, which was added on, as you can see here on the right, to the historical building that housed previously the Fitz refractor. It was connected by a covered passageway, and this new dome cost $2,332.69, and bringing the combined cost of building and telescope to over $6,600, well, $232,000 of today. Let's look inside the dome. So what you see here is a magnificent 10-inch Alvan Clark refractor, ready for watching the stars and teaching countless students about the science of the universe. The telescope was central to hands-on education, and Professor Isaac Sharpless emphasized experiential learning, and his textbook, Astronomy for Schools and General Readers, reflected the instructional value of directly observing something in the sky. Generations of students studied the sky using the Clark, gaining practical experiences in celestial mechanics and optics. And here's a picture of the book on the bottom also. And if you like to look at this historical astronomical textbook, come out to Chiefland. We have a copy of it on display in our museum. And that copy is actually from that right time when Isaac Sharpless was teaching at Haverford. And for some fun, let's take a look inside that book. Here's a picture from page 253. And I'm going to see if you can guess which object Isaac Sharpless sketched here. What does it look like? Well, the sunspots are on the book. That's good. I've the picture in the middle. What does it look like? Which object might that be? Okay, I think I heard the right thing, so say it a little louder. That's the Orion Nebula. Correct. Messier object 42. Very good. Let's see if this one. This one's a little harder, I think. It's on page 258 of the book. Really fast. Excellent. This is indeed the Dumbbell Nebula in Vulpecula, Messier 27. Here's another one. That's the Whirlpool Galaxy, the Spiral Galaxy, Messier 51. It's on the page before the Dumbbell. And what he calls it is a spiral nebula. I kept the caption on here, spiral nebula. And it turns out in the 1880s, it was known as that, Messier 51, the spiral nebula in Canes Venatici. And the nature of these nebula was not yet understood. Sharpless correctly pointed out in his book, however, that spectroscopy showed that these nebulas are not gases, but even the largest telescope cannot resolve them into stars. So they weren't sure what they were. That took a few years and a few more astronomers to actually figure out that these are distant island universes. On page 264, Sharpless describes the nebula hypothesis, and he makes clear that these nebulas, which are not made out of gas, are not those. The nebula hypothesis is a theory that every star with its attendant system of worlds, so he also speculated that most stars out there have planets around them, was at one point in the form of a gaseous nebula. And if you look at that, astronomy has indeed come a very long way since the 19th century. But interestingly enough, many of the important ideas were already there. So among the great users of the great Alvan Clark refractor was also Francis Leavenworth, a rising astronomer who joined Haverford a little later in 1887 as the director of the observatory. Using the Clark, he carried out precise micrometric double star measurements, and he published those in the Haverford College Studies a few years later, and his work contributed to various national efforts to catalog binary stars and underscored the role of the 10-inch Clark in advancing science. In 1930, after nearly 50 years of service, the telescope was reconditioned by the Fecker Company, which were specialists in telescope restoration. Fecker replaced the original steel tube with rolled aluminum tube, which was significantly lighter, and they refurbished the mount and the drive systems. Also, Haverford built a new observatory, the Strawbridge Observatory, which is still in use today, and you see it here on that lovely picture. The Clark remained in the dome in the Strawbridge Observatory until 1999. After more than a century of continuous use, it was finally retired due to tracking failures, so the mount wasn't tracking as well, and the chromatic aberrations of the 10-inch achromatic lens. Yet, the Clark refractor was not discarded, fortunately. It was sold to a Florida-based optical engineer, Jan Segalski, and an amateur. He's also an amateur astronomer, and he had plans to restore the telescope. Unfortunately, that did not happen. In 2003, the scope changed ownership. Mike Toomey, who many of you may know, bought the scope. Mike is an AEC member. He's online, I believe, right now. And his foundation supported the Planet Walk in Gainesville and various other efforts, including 2 solar telescopes the club owns. Mike had planned to bring the Clark refractor back to life, but did not get around to it either. Well, this brings our journey back to Earth. So we're back from the Zubin al-Shamali, we're back on Earth, and we're back to the current time. And we're at the Chiefland Astro Spring Picnic a few months ago. You see us here installing the sign at our museum. At that occasion, we officially dedicated the Chiefland Astronomy Heritage Museum. And a few days after we did that, I received an email from Mike asking if we were interested in a 10-inch Alvan Clark refractor for our museum. Well, you can guess my excitement, and you can also probably guess my response. Well, it was a clear yes. And so that started Project Alvan. Project Alvan was born that day, and this 140-year-old museum is now in caring hands once more. Let me tell you a little bit what happened next. So we met with Mike, and we were able to bring the telescope part back to Chiefland. Here we are picking up all the pieces, loading various cars, driving them out to Chiefland, and then we cataloged them and looked at a few of them. What you see here is actually not the Alvan Clark. This is a 3-inch finder scope of the Alvan Clark. It's also an Alvan Clark, right? And it was actually in very good condition. And thanks to Dave, who actually took care of it a little bit more, made sure it's polished, cleaned, and everything. It's now ready to be installed back on the scope. So this is what a 140-year-old finder scope looks like, and I actually brought it here today. So during the break, we're going to take it out. It's in the box. It's in the case here, and you can all take a look at what a finder scope used to look like. And you might want to compare that with the finder scope on your scope. Certainly none of the finder scopes I have look like that. Well, we're going through the various crates. We cataloged all the various telescope parts, and what you see here is a massive 4-inch focuser. That focuser is about this long, 4-inch in diameter, right? Weighs 43 pounds, and it's in very good condition, actually. So it's probably pretty easy to restore. We'll probably need some paint, lubrication, and some adjustment. And with that, it should have no trouble holding these tiny eyepieces I have over here in this historical telescope. So those eyepieces are about 1 inch in diameter. They weigh nothing. They weigh about a couple ounces. So not sure why that focus is quite that large, but it's very impressive. What I show you next is actually the most important part of Project Alvan. This box, as it says on the top, contains the objective lens, the 10-inch achromatic doublet lens designed and polished by the master, Alvan Clark. Opening it up, there it is, a little piece of paper in it with a note that we know what we're looking at. This is a 10-inch achromatic Alvan Clark lens. It's in good shape, has a solid brass mount, and will work to ensure that it will focus starlight again on our eyes in the 10-inch Alvan Clark refractor. Unfortunately, not all parts of the telescope did so well over history. What you look at here has the color of Mars. Mars is mostly made out of rust, and the mount and pier is what that is. And the mount and pier clearly have seen better times. They will need some major restoration effort before they can be shown in the museum again. For structural reasons, we actually plan not to have the mount and pier carry the telescope again, but instead being restored for visual admiration of that historical instrument, and we're going to put a replica telescope on top of it. To give you some idea of what we have in mind, we'll now travel to the future. So they look a little different, those pictures in the future, they're not really photographs. And here's what we envision the restored pier and mount to look like, the restored pier and mount is on the right here, to look like in the museum. Something like this, with a replica of the actual Alvan Clark refractor on top of it. So we'll create that replica. We'll use Dave's great skills for that to make it look exactly like the original Alvan Clark looks. On the left, however, you actually see what we envision the telescope to look like in the dome. It's going to get a modern mount, and it's going to be mounted in the dome, installed in the large dome out in Chiefland. And if our measurements and math are correct, it will just fit. So right now I measured that I got 2 inches of clearance on the top. So keep your fingers crossed. It will be mounted on an altazimuth mount for a couple of reasons. Main reasons is actually stability and also safety. We want to make sure that that thing doesn't swing around and hit one of the students or visitors in the process. That would not be fun. So to make this dream come true, we really need everybody's help. The dome needs renovation. It needs walls and floors refinished, insulated. The roof needs some repair and repainting. And we need to install some AC and humidity control in the dome to make sure that that 10-inch Alvan Clark is going to survive for the future. So if you'd like to be a part of Project Alvan, we're looking for any contributions to support the dome renovation, telescope restoration. So please feel free to take a look at our GoFundMe page. Here's the QR code for it. And any contribution will help the Alvan Clark to again become operational and accessible to students, visitors, and the public. In restoring and preserving this remarkable instruments, we will honor both its scientific legacy and its lasting contribution to astronomical education. So thank you for listening, and thank you for your support.
We have a message from the chat. Mike Toomey says, looks great. Good work, Dave.
Thanks, Mike. Any questions for Richard?
Oh, very nice presentation. And I'm glad it's going forward, because I remember when Mike first acquired it, we had great problems about figuring out what to do with it. You made a statement at the beginning I was a little puzzled about. You said that there were no Clark refractors in this area.
Large Clark refractors. I know that UF has one, but I'm talking about 9-inch or larger.
Well, the university has an 8-inch.
An 8-inch, that's right. That's why I meant, so I looked it up, and there's really nothing 9-inch and above in the area. So the smallest, 8-inch is the largest, and that's at UF on campus. That's correct. Thank you.
Karen Johnson says, 2 inches clearance. You are a brave man, Richard.
Well, we'll see how it goes.
Street says, what are all the cables in the original picture?
All the cables on the telescope. Let's go back to that. So all those cables here, what you're going to see in here, those are actually the controls to move the telescope in RA and DE. Those are the slow motion, essentially, I believe. So looking at the pieces we have most of the parts of that actual mount. So those pieces are actually there to move the telescope.
Got another question in the back there?
There's 2 domes near the museum in Chiefland. Will the Alvan Clark be going in the smaller of the 2?
The big one. There's no way it fits in the small one.
Okay.
And the big one, which is smaller, smaller than this, but not dramatically smaller than this. It has a little of the same kind of feel to it, but it is smaller. And it will roughly touch the dome shut in the top. That's why an altazimuth is actually the better mount. Then equatorial wiggles around too much. That's too little control. And we have it, if the mass is right, when it's right at zenith, We can see at zenith, and we're gonna sit in a chair like this, look through the eyepiece. And then when it's go down to 30 degrees, we have a little step ladder, and we're gonna look through it. It should all work. But it's gonna require a lot more measurement and confirming that it's really true.
Aaron Johnson says, Richard, Larry here, do you know the condition of the lens coatings?
It doesn't have coatings. That was before coatings. So that's helpful. The lens looks dusty, but I think it's okay. It doesn't have any scratches, no fungus. I haven't started cleaning it. I want to talk to some professional telescope and lens makers first to see what's the right thing to do with. Also, do we have to take it out of the lens cell, for example? I don't know that yet. Probably do and clean both sides before we put it in there. I'm going to talk to some of the modern lens manufacturers and see what the right strategy would be. Might have to drive it across the country for that process.
Looks like Tom and Joe have questions.
Yeah, the description of the dome says it's air conditioned,
No, it will be air conditioned.
but not while observing, right?
No, the point is to install humidity control and air conditioning to keep the telescope dry during daytime and under not observing, and to cool down the dome to night temperature before we start opening up at night. Right? A 10-inch achromatic refractor, which has a 220-pound steel and aluminum tube to it, is an awful lot of solar of mass and thermal mass, and so you want to cool that down before it gets dark to the expected temperatures at night. So the idea would be, oh, it's a 68-degree night. We'll set the thermostat to 68 2 hours before sunset, and then open up and start observing without any issues. That's a dream.
The original drive unit on that was a weight driven, was it not? With a clock escapement?
That's
I
an
think it was.
excellent point. I know that the Fecker repair put an electrical drive in there. The original one,
Is any of it left?
we don't have the original mount drive. No, we have the 1930 replacement by Fecker. The original was lost to history. I don't know. I guess in the 1930s that was put in a dumpster. And that the 1931 is an electric motor was in there. We do have those pieces. They were taken out of the pier, I believe. I believe I have those in Chiefland. The pier itself just has a mounting bracket for it, I believe. But some of these things we really need to still investigate more carefully. We've looked at the lens, we've looked at the two parts, the mount parts. There's a lot of boxes.
Isn't it the case that it is possible that that lens was the last one that Alvan Clark himself may have polished?
I think that's correct. So there's no good records about it, but he was alive at that point still. And the books I read about Alvan Clark making the telescope, he was still polishing lenses at that time. He may not have done it all, but he certainly had his hands on these things still. Yeah, may have been the last one.
The 8-inch UF was made later.
So that was by Alvan Clark and Sons. Yeah. They're all really good, right? And they're a lot of fun.
Okay, any other questions?
To me in the chat says, that is my opinion as well. A Clark's class large lens.
Yeah. That would be really cool. That's certainly the slogan. We'll go with that, right?
Yeah.
Alvan's last lens.
Okay, if there's no further questions, I'd like to present you with one up. Did you have another one?
Another chat.
Oh,
That makes it even more important to story.
yes.
Yeah.
Okay, we'd like to give you a token of our appreciation, a 2016 Galileo €2 commemorative coin uncirculated.
Oh, that's wonderful. Thank you. And I'm going to show the finder now. I think we're going to take it out on one of the tables and then take a look at it, what it looks like. Right? Yeah, a proper finder.
Okay, let's take a 15-minute break and we'll see you back in here.
Our friend who likes to sit there, he does the finger puppets in front of it. Okay, so the show was produced by the Bates Mountain Planetarium in Kingsport, Tennessee. If you ever get a chance to go to Kingsport, they have a great nature preserve there, and it's a nice weekend of being up in the mountains and stuff like that. It's very nice. So that planetarium produced the show more than 10, a little over 10 years ago. So you'll learn about you'll learn about the probe. You'll learn about what I'm blanking on it. I'm sorry, my brain is not working right now. the equipment that they put on the thing that went out there. That's what you're gonna learn. All the science experiments and so forth. And at the end of it, I'm gonna come back in here, I'm gonna tell you an Apollo 13 moment that they had with New Horizons 2 days before it got there. So, Apollo 13, i.e., it was a mission ending issue, but they were able to solve it. Thank goodness. So, you know where the emergency exits are. If you haven't been here before, we have 2 emergency exits, one to the left and one to the right. When you go through those doors, walk down the short hallway, open the doors at the end of the hallway, and that puts us in the rock cycle garden behind the planetarium. Now, during full-dome presentations, there are times where you may feel as if you're moving, so at any point, if the visuals become overwhelming, just close your eyes for a few seconds, and that feeling will go away. Now, halfway through the show, there's going to be an interlude or an intermission where we will try our hand at looking at Pluto using the same technique of using a blink comparator. So I will be back in here to narrate you through that part. So, but Brian, thank you so much for being a very good co-host and Zoom and stuff like that.
I've stuck by you through worse.
So yeah, I've been on the other one, Dean Regas from the Cincinnati Observatory. They do their starry, it's a class that he teaches on the night sky, and he invited me to be one of the panelists. So he and I have been reminiscing about stargazers and stuff like that. So he'll send me the recording and I'll send it to you all so you can watch what I was doing. And we give a shout out to the Alachua Astronomy Village. Yeah, since y'all are here. Alrighty, so I think that's it. Everybody ready? You excited?
Yes.
Almost as excited as Joe? That monolith, that's I am very proud of you. Yeah, it's like we have science fiction royalty in the room. I'm just amazed. It's like having Isaac Asimov in the room with you. It's like you don't understand. It's
I'm less dead.
yeah, you're a lot less dead. Yeah. Okay, so off we go with. You have the speaker right behind you. Yeah, right? Yes. Dim that or. Okay.
It is an inherent quality of humanity to explore the unknown. Always searching, always going around that next corner. Our survival is linked to this undying characteristic. We dare to ask, why? Why does this bright object we call the sun seem to rise on one side of the sky and set on the other? What are those tiny points of light in the nighttime sky? And why do some of them seem to move, while all the others continue to show their unchanging celestial patterns? We shall forever be asking, why? We shall forever be exploring new horizons. The night sky, always fascinating, always tempting us to ask, why? We see the brilliant stars in the nighttime sky. They reveal to us a multitude of wonderful pictures and stories. As the seasons carry on, these nocturnal pictures change too. These constellations seem to shift across the sky, revealing a whole new picture book for us to enjoy. In ancient times, there were 7 special objects seen in the sky. 2 were the sun and the moon. The other 5 were called planatia, or wanderers. We know them as planets. These objects look just like the stars, but they mysteriously moved across the sky against the background fixed stars. Notice that the Earth is not part of this group. We live on the Earth. It couldn't be a wandering star in the sky. Prior to the 17th century, the common understanding of these wanderers was that they were unique stars that were inhabited by gods or goddesses, or they were at least under a special force that allowed these objects to travel about. How else could a star move across the sky? As time goes on, our curiosity forces us to learn more. It took the daring of Polish mathematician Nicholas Copernicus and Italian scientist Galileo Galilei to ask why. Copernicus, using his own reasoning, was able to publish the correct understanding of the solar system and its planets in the mid-16th century. He concluded but did not prove that the known planets revolved about the sun. Almost 70 years later, it took the advanced technology of the early 17th century to reveal what was suspected. Using a small handmade refracting telescope, Galileo's observations showed that the planets orbited the sun, and that the Earth was not the center of the solar system. Galileo changed everybody's understanding of the heavens. He didn't do it for self-promotion nor to create a stir. He did it to reveal the truth. Another 75 years would pass until British scientist Isaac Newton proved that the planets went about the sun. He used a common force known to exist throughout the universe, gravity, to validate Copernicus and Galileo. When we find out why, we must then accept change. In addition to Galileo's amazing discoveries, he developed the modern form of what is called the scientific method. This is a rigorous process used to arrive at an unbiased result to reveal the truth in all forms of science. We may think something occurs due to some force or method, but that does not make it right. The answer to understanding why something occurs is the result of gathering data, testing the results, and then letting your peers reproduce your results. If observed results match the original idea and your peers agree with it, we then call it a theory. This precise exercise has come up time and again with regard to the exploration of and discovery in our solar system. Ever since Galileo used his simple telescope on the night sky, it has become the most important technical tool of discovery in astronomy. It allows us to see faint, faraway celestial objects clearly and with great detail. The 18th century saw the addition of a new planet beyond the known 6 planets. In 1781, William Herschel, British astronomer and musician, discovered the 7th planet, although purely by luck. Herschel was scanning the skies with his large reflecting telescope and came across this small bluish first ball. He thought it at first to be a comet, but later realized that it was a planet. We call it Uranus, although this was not the first proposed name. Herschel wanted to name the planet Georgium Sidus, for the Georgian planet. This was to honor Herschel's benefactor, King George III. Of course, this was not accepted by the astronomical community. It was decided by the same group to follow the convention of the 6 other planets and name it along the same line of Roman gods. Since Saturn was the father of Jupiter, Uranus would be used next, as he was the father of Saturn. Now the race was on for more discoveries. Who wouldn't want to discover a planet in our solar system? The 19th century would see mathematics as a new method for discovery. Accurate measurements of the position of Uranus divulged that a mysterious force was being applied to this planet. What could be causing this force? It was quickly realized that another unknown planet's gravity was the source. Neptune's discovery took years of scientific measurements and difficult mathematical equations. The calculations based on these measurements would point to the part of the sky to search, to find the next planet. Two different astronomers in two different parts of the world both use the same method to find Neptune. A young and unknown British astronomer, John Couch Adams, and Alvan Clark, a well-known and established French astronomer. Both used mathematics to determine where to observe and sought out other astronomers to look for the planet. Neither Adams nor Leverrier had a telescope to use whenever they wished. It turns out that Adams was first incorrectly calculating where Neptune would be found, but due to his unknown status, it took a long time for him to get an observing astronomer to look for his findings. Leverrier calculated Neptune's position later, but it was confirmed prior to Adams, thus garnering Leverrier the honor of discoverer in 1846. Would there be more? Percival Lowell, in the late 19th century, was the perfect person to look into this mystery. Through more mathematics, based on the gravitational effects on Uranus and Neptune, a focused region of the sky was examined. Lowell, however, passed away before he could conclude his search. A decade after Lowell's death, a young novel astronomer named Clyde Tombaugh was hired to continue this quest. Tombaugh was quite precise in his scientific approach. He knew he was looking for something that was extremely faint and would be moving across the sky at a very slow pace. Mathematics dictated what area of the sky to search, but traditional observational methods would not work. One had to photograph the same parts of the night sky many times, with days and months between each image, in order to see any change in position of this unknown object. This movement over time would reveal its proper motion against the background stars. Photography was a new technical tool in astronomy. It allowed astronomers to record the extremely faint light of objects that could not be visibly seen through the telescope. A photograph will gather this light, no matter how feeble, over time, as long as the photographic plate is exposed to this starlight. Tombaugh used this modern technique and focused on the part of the sky that we know as the constellation of Gemini, the twins. After endless photographic glass plates and nearly a year's time, Pluto was discovered. The method used in Pluto's discovery involved a blink comparator. This was a special device that was similar to the microscope, but instead of a tiny sample to examine, this microscope was looking at two different, huge photographic glass plates. Each of these plates contained the tiny images of over 150,000 stars. Today, computers do the searching for us to discover new, faraway solar system objects. Tombaugh, though, had to compare every plate manually. The blink comparator would allow Tombaugh to see one tiny part of one photograph and compare it to the exact same part of the sky in the second photograph. His goal was to see something shift across the image between the two plates. He would compare every part of every pair of photographic plates, going back and forth for every star. Most wonder how he achieved this amazing task in less than 1 year to discover Pluto in 1930. Pluto was considered a planet upon its discovery, and so it was eventually named along the same convention as Uranus and Neptune. After 1,000 different name suggestions, Pluto was named after the god of the underworld for its extreme distance from the sun, and thus its dim existence. This name did not come from an official body of astronomers, but from an 11-year-old British girl from Oxford, Venetia Burney. As a tribute to Percival Lowell, the symbol for Pluto was designed to represent Percival's initials, PL.
Hi. So we're going to take this little opportunity to give you the ability to find Pluto. So this is a picture of the sky from January 1930, and we're zoomed in the constellation Gemini, and we're going to split the sky into 4 sections. So we have quadrant number 1, then quadrant number 2, quadrant number 3, and quadrant number 4. We're going to flip the image back and forth by a period of about 2 weeks. And I want you to clap your hands if you see at least one thing moving. Good. Yeah, obviously it's this big thing. Now, clap your hands if you see something else moving that's much smaller. Awesome. And what quadrant is it in? Good. That little thing right there is Pluto. Now you have to keep in mind, Pluto is extremely far from the sun. So it doesn't reflect a lot of light, and because there's not much light out there, so it makes it very, very difficult to find. So yeah, it's a miracle that he discovered that in such a short period of time. So give yourselves a round of applause for discovering Pluto. And Walt Disney, apparently, according to legend, he liked the name so much that later on that year he gave that same name to Mickey Mouse's dog. Yeah. All right.
Our understanding of the solar system is much more complex and richer than it was in the 18th to early 20th centuries. This is due to the advancements of the telescope and the exciting new methods of exploration. Satellites orbit the Earth. Amazing landers and rovers physically explore, though just a small part of the solar system. Space probes have traveled to the outer regions of the solar system and continue to explore well beyond our reach and even beyond our imaginations. Each new discovery forces us to be a greater part of this huge place we call the cosmos. Yet, our solar system is just a tiny part. Mercury has been explored most recently by the orbiting Messenger spacecraft. It has mapped the entire surface of Mercury in great detail. Like our moon, its heavily cratered surface reveals the chaotic past of our solar system. The second planet from the sun, Venus, hides its features from us with its thick covering of clouds. Radar and other detectors allow us to see through its opaque shroud. Though Venus was once thought to be Earth-like, new evidence has forced us to change our understanding. Instead of mysterious forests and creatures, we find huge volcanoes and endless sparks on a desolate landscape. The fourth planet, Mars, has always intrigued us. Our ability to almost truly detect what is on the surface has sparked our imagination. In fact, Percival Lowell was convinced that he saw canals and cities on Mars. But we know that Mars is a desert-like planet. Landers and agile rovers now dot the surface for a new era of discovery. Beyond Mars is a region known as the asteroid belt. It is inhabited not by a single planet, but by hundreds of thousands of pieces of rock and metal orbiting the sun. The largest of these objects, Sirius, was discovered in 1801 and was quickly labeled a planet. As the years passed, more of these objects were found in the same region of space. It became clear that they were much smaller than originally thought, and so they were renamed minor planets or asteroids. We now enter the realm of the Jovians, 4 immense planets being mostly of hydrogen and helium. Jupiter and Saturn are called gas giants. Uranus and Neptune, being much further from the sun's warmth, are called ice giants. Launched in 1977, the Voyager spacecraft have unveiled the mystery of these planets. They are still operational and over 100 times the distance of the Earth to the Sun. They are the first true explorers to sail out to the stars. But what about beyond the royal realm of the Jovians? Since the discovery of Pluto in 1930, we have discovered many objects past Pluto that were not tiny, but were clearly much smaller than Pluto. But in 2003, Eris was discovered. This troublemaker turned out to be about the size of Pluto. This new development was the turning point for understanding this area of space. Just like the story of change in the asteroid belt, we must follow the scientific method, remove our personal bias, and look at just the facts. Pluto's family just became larger. It wasn't alone often, far out into deep space, slowly orbiting the sun in 248 years. It became part of a larger group of objects now known as the Kuiper Belt. In addition to being a Kuiper Belt object, Pluto is also known as a dwarf planet. What it is not called is a planet. A Kuiper Belt object is any object that orbits the Sun in a range of distances of 30 to 50 times the distance of the Earth to the Sun. It's just like the asteroid belt, but much further from the Sun, just past the orbit of Neptune. It contains hundreds of thousands of objects as well, and may stretch into millions. A dwarf planet differs from a planet by only one point. A planet orbits the Sun, is large enough to have sufficient gravity to round itself out, and orbits the Sun with no other similar-sized objects. A dwarf planet, like Pluto, also orbits the Sun, is large enough to be round, but it orbits with other similar-sized objects. These orbital brethren have interesting names like Koala, Sedna, Maki, and of course, Eris. Other notable members of this elite club include Ceres, the first asteroid discovered. Another is Pluto's largest moon, Charon. The Pluto system and much of the Kuiper Belt are composed of a 50-50 mix of rock and ice. Pluto is about 2,400 kilometers wide. Charon's about half that. This close ratio of Pluto and Charon's size make it a double dwarf planet system. Both orbit each other in an off-centered cosmic waltz. Not much was known about distant Pluto. Even with the keen eye of the Hubble Space Telescope, the best we could see was a rough map of dark and light areas of Pluto's surface. Questions still remain. What was Pluto like? Exploration of Pluto culminates with the flyby of the New Horizons spacecraft. This craft is designed to learn about the Pluto system as well as at least one other Kuiper Belt object.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decoy. It's amazing to get Pluto and the beyond.
New Horizons travels fast and lean. Launched at the dawn of the 21st century on January the 19th, 2006, aboard an Atlas V rocket. It sports the fastest launch ever with a speed of 57,600 kilometers an hour.
And we have photo, are you maybe strong enough to read from?
T plus 1 minute 45 seconds. Everything continues to revolve.
1, 2.
Boosters have just jettisoned.
5, the first one's good. And we have space preparation.
To honor Pluto's discoverer, Clyde Tombaugh, a small amount of his ashes have been safely cached within the crown. The extra thrust behind its launch, along with a gravity assist by Jupiter, allows New Horizons to catch up to its target in only 9.5 years, reaching Pluto on July the 14th, 2015. New Horizons is packed with technical wizardry that would make any scientist envious. It has the LORRI, or long-range reconnaissance imager, to provide high-resolution pictures for all of us to enjoy. There are a pair of spectrometers named Ralph and Alice. Their honeymoon is time close approach. Spectrometers use very specific wavelengths of all types of light to determine an object's composition. Alice looks at the extremely thin atmosphere of Pluto, created by numerous ice geysers. Ralph focuses on the surface to see its makeup and temperature. SWAP, or Solar Wind Around Pluto device, in tandem with Pepsi, or Pluto Energetic Particle Spectrometer Science Investigation, scans for charged particles about the Pluto system to see how Pluto reacts with the sun's solar wind. Utilizing the spacecraft's antenna, REX, or Radio Science Experiment, looks at Pluto's atmosphere and establishes its composition and temperature. The SDC, or Venetia Burney Student Dust Counter, looks at dust, an important sensor since any fragment, no matter how tiny, can spell disaster when a spacecraft is traveling at such high speeds. This instrument, true to its title, was built by students, a first in US space history. Many of these instruments have built-in redundancy, although there is something different about each as well. The reason is simple. If any of the instruments fail, another can compensate for it in some fashion. Exploration on a distant sea, especially the ocean of space, includes unknown dangers and hopefully amazing truths. Much has changed since the launch of New Horizons in 2006. Pluto was still considered a planet. Pluto is also known to have 3 moons, Charon, Nix, and Hydra. Its 4th and 5th moons, Kerberos and Styx, were found in 2011 and 2012. This was interesting news for astronomers, but news of change for the team who have built and controlled New Horizons. More moons orbiting Pluto. They may have been formed from a collision of a past object with Pluto. As of 2012, this also meant that there could be a ring system. Fascinating and devastating. Rings meant a beautiful sight. It also meant a hazardous minefield. Pluto is already becoming a complex system of large and small dwarf planets, moons, possible rings, and dust. Lots of dust. New discoveries have forced us to change our understanding once again. As New Horizons approaches Pluto, data is collected using its detectors. During the 4 months prior to closest approach, The potential for hazardous dust impacts are assessed. If collision is imminent, then New Horizons is instructed to swing its large antenna forward to act as a mighty shield against its particulate foe. Data transmission from the craft to Earth is a challenge that must be choreographed. At an immense distance of 5 billion kilometers, it takes 4.5 hours for communication to be complete, one way. The craft is designed to use multiple instruments at the same time, and it needs to send that data back home. During the months prior to close approach, data acquisition will not overtax the data transmission. During the 10 days that lead up to the flyby of Pluto, all instruments will be on full throttle, filling up its internal storage far faster than it can send the data back to us. It only takes a meager 6 hours for New Horizons to pass by the Pluto system. But more than a year will pass before all of its stored data is sent back home. But that's not the end of the ride. New Horizons continues on to other Kuiper Belt objects. We are, all of us, at the beginning of discovery of a new frontier. The unknown is just that. It begs us to explore new horizons.
I hope y'all enjoyed that. And since the music is up, let me you go ahead and do a little bit of this. Yeah, like a dance party. Whee! $25,000 worth of technology, and all I do is play with the lights. Okay, so Brian, when after the island's done, it's gonna get brighter, but then I want you to bring up the full brightness gradually. So there was just before New Horizons got there, because it took a long time for it to get there. So most of the time it was asleep, like I would want to be if I were traveling that far.
Ready?
So it woke up a little bit when it got near Jupiter because they wanted to take pictures of Jupiter and so forth as it flew by, and then it went back to sleep again. But as they were approaching Jupiter or approaching Pluto, they woke it up and it started doing its thing. And it started collecting so much data so quickly that the computers, you know what happens to a computer, blue screen of death, boom, and it locked up. Now, they had forgotten that if that happens, there was a special protocol the spacecraft was scheduled to do if that ever happened. So, because there's no way you can fix anything out there, but if the computers had rebooted, it was going to automatically orient itself so the antenna was pointing toward the Earth so it could communicate. And it was going to start, it had little jet rockets on it, so it would start to gyroscopically spin so that it would stay on course, just in case it got off course. And it would start transmitting on a separate signal but the crew, the people, 10 years. So they said, oh gosh, we're not getting any telemetry. What's going on? So they had to go through the manual and then realize, oh, it must have had a data, it was collecting so much data that it just locked up. So they went and looked in that, they listened for that signal, and they did hear the signal on special frequency. So here's the thing. They are less than 24 hours from getting to Pluto. This mission has taken almost 10 years. It's only going to take them 6 hours to go through the Pluto system because they're going so fast. So they had to write a computer program to tell it, okay, we want you to go back to what you were doing, but this time we want you to store information in different parts of the hard drive and not try to send stuff back at the same time you're collecting stuff. Because if it's spinning, you can't take pictures of it spinning, and it's not pointing in the right direction. Yeah, so they wrote the computer program and then they sent it off to Pluto. And how long does it take for light to get to Pluto? Almost 4.5 hours. Yeah, so it took 4.5 hours to get there. Then it had to run the program. Then it had to send a signal back to say, hey, I got it and I fixed everything. So then we had to wait another 4.5 hours to come back. I couldn't imagine being on that team waiting 9 hours. I'm like, oh my God, we are like almost at Pluto. It's like you're driving from here to California or to Los Angeles, and you're right outside Los Angeles, and your computer, like your tires don't flat. So I don't know. But they did get everything fixed. Hooray. So they took pictures of Charon and Pluto, and we now, all of us in planetariums who have digital systems, we have three-dimensional maps of the surface of Pluto now. So if you go to solarsystem.nasa.gov, they keep changing the website, but they have a pull-down menu that has the planets, the dwarf planets, minor planets, asteroids, and so forth. And you can go down and find Pluto. They have a whole page devoted to Pluto, and it has all the images that came back and what the materials were. That Pluto actually has an atmosphere, but it's very, very tenuous, and it's very cold. But they were surprised to have an atmosphere. They took a picture of you guys took a picture of Pluto from the nighttime side, and we saw this haze around. It's like, hey, it's got an atmosphere. Because people used to think that Pluto was bigger than Mercury, but as our technology got better and we had better telescopes, we realized, oh, it has a moon. We discovered the moon of Charon, or Sharon, however you want to pronounce it, back in the late 1970s, about the same time we discovered the rings of Uranus. Because Uranus is tilted on its side, so when it was passing in front of stars, you saw the stars winking on and off as Uranus is going by. It's like, it has rings. So, anywho. But I want to thank you all so much for visiting the planetarium tonight, and those of you on Zoom, if presuming you can hear me, thanks for joining us. So, our guest speaker next month, did you already announce that?
Yeah, we were trying to get Dr. Lee here. She was supposed to be the speaker.
Okay, well, hopefully we'll be able to get that done, and we'll be here, same bat time, same bat channel.
Mike Toomey says 4.5 hours. That's just a day trip.
Well, yeah, if you're going to Atlanta.
Mm-hmm. Yeah.
Well, if you're traveling the speed of light, yeah, you can get from one point of the solar system to the other pretty quickly. But if you're trying to go anywhere like a nearest star, to give you an idea, if you know the sidewalk past the planetarium, there's Memory Tree Renew, the police department, and you have the administration building down at the other side where there's a little golf cart. So when you leave the planetarium, you look down that way, you'll see a golf cart. Look back, you'll see a tree. That tree represents the sun. Mercury, Venus, Earth, and Mars, their orbits are all between that tree and the entrance to the atrium for the Natural Sciences Building. When you get into that breezeway, Jupiter is about where the metal door button is. The metal button is to open the automatic door in that breezeway. Saturn's orbit is near where our sundial pedestal is here at the planetarium. Uranus's orbit is when you go into the next building, that breezeway, the tunnel that goes down to building G where the alphabets are, that's Uranus's orbit. And that golf cart all the way at the end of the entrance to the administration building, that's where Neptune's orbit would be. On that scale, do you know where the nearest star, Alpha Centauri, would be? Atlanta, okay. Okay, it will be in Virginia. Yeah, like Richmond, Virginia. Really, really far. And so between here and Richmond, there's nothing. No stars, no planet, maybe rogue planets, lots of comets. But anyway, so I'm going to turn it over to our president.
Mike Toomey says, thank you as always, James.
Oh, Mike Toomey said thank you. Oh, wait, Toomey.
Yes.
Oh, hi, Mike.
And Jerry says, I see the heart on Pluto. And Mike's guess for the distance was Egypt. For like where Alpha Centauri would be.
His guess was Egypt.
Yes.
No, that's too far. But there would be another star that would be probably. Yes, sir.
I think on a scale of basal solar walk, Pluto's in Egypt.
Oh, okay, that works. Yeah. Okay, yeah, so Jerry is correct if you use the solar walk. I gotta find out what the scale speed would be driving down at the speed limit, how many times the speed of light you're actually traveling. Yeah. Yes, sir.
I've done it. It's like 35 times the speed of light if you're doing the speed limit.
Oh, okay.
Or mixing that up with the speed limit, but you're going well in excess of the speed limit.
If
you're going
doing the speed
35.
limit.
Well, it's lively, so, anyway, I'll turn it back over to you.
Okay, anybody got anything else? Now, we hope to see you on Zoom on the 15th, and then at the start party treatment on, thanks for coming. And make sure you're scared, make sure you don't.